Yes, thank you, and good morning, everybody, in this QA breakout session with our talk about continuously test embedded systems, keyword-driven, with Qt's Squish. Before we start, allow me to introduce ourselves. My name is Björn, and this is Miguel. We are both part of Team Comlet and the tech team test engineering and validation. And at Comlet in general, we are adding value to our customers as a technology partner for over 20 years now, with dedicated solutions regarding security, applied AI, and test automation. And in our tech team in particular, we focus on quality engineering with the help of test automation. So, the agenda for today. In the first half of this talk, I'm going to introduce all of the technical terms that are necessary to understand and to follow this talk. I'm going to talk about the challenges that we usually face in our projects, together with the motivation how to overcome those. After that, Miguel is going to showcase you a real-world scenario that we are currently implementing together with one of our clients. And at the end, we are looking at some lessons learned that we have concluded already, and of course are happy to answer all of your questions. At least we try. So, starting with the first definition of a technical term, which is the one of continuous testing. And according to the ISTQB, continuous testing is an approach that involves a process of testing early, often, and everywhere, and automate to obtain feedback as rapidly as possible. And applying to this definition of getting feedback as early as possible, for us, this translates to the integration of automated tests as a quality gate into a continuous integration pipeline. The result of this, every code change triggers automatically and continuously the execution of the automated tests as regression. Embedded systems are best described by some of their key properties that distinguish them from personal computers or workstations. And three of those key properties are that an embedded system have a dedicated, single, and foremost specialized functionality only. It is embedded into a larger system, hence the name embedded. And the resources of embedded systems are limited, at least more limited compared to the personal computer or workstation. What I have not mentioned in this key property list here is the operating system. Because, or better, I mean the lack of an operating system, because today's embedded systems work perfectly with real-time operating systems or even specialized Linux distributions. So bottom line, from a practical point of view, the workstations from 10 to 15 years ago are today's embedded systems regarding their resources. Keyword-driven testing. Keyword-driven testing is an ISO standard that shall enable everybody to define and understand test cases and their use cases. And the emphasis is really on everybody here. And the reason why is because keywords are building blocks to create test cases without requiring detailed knowledge of programming or test tool expertise. And they are domain-specific, so it's a domain-specific language. What keywords are explicitly not, they are not of any standard computer programming language. So to give you an idea how this may look like, here is an example test suite with an example test case starting from line 9 with its name login user with password. And if you read carefully, we claim that everybody of us in here, no matter of the professional background, everybody of us in here can understand what this test case basically verifies. So now that we know what keyword-driven aims for, we need to understand that there are different types or hierarchies of keywords. There's the keyword itself, which is just one or more words to be performed during the execution of test cases. There are high-level keywords, which are composed from other keywords. It could be the lowest level of keywords, the atomic keyword itself, could be other high-level keywords, so you build up a certain hierarchy. And the highest level of keywords, they are usually used to assemble the test cases. And there are keyword libraries, which are sets of keywords reflecting the language and level of abstraction used to write the test cases. Let's have a quick look at Squish. I assume many of you have already heard about or used Squish already, so I try to make it quick. Squish is an automatic graphical user interface testing toolchain that involves a lot of beneficial features that makes the life of a test automation engineer easier. And as we heard this morning in the previous talks, there are coming even more features that make your life as an automation engineer more easy. And Squish supports several platforms, all of the major ones, and of course some of those, some of specialized ones. How Squish basically works is there's a Squish runner, which is responsible for executing the test scripts. And the test scripts, they can be of any multiple real-world scripting language, like Python or JavaScript, for example. There is even an optional Squish IDE with a screenshot here on top, which has also some beneficial features like test creation, recording, playback, debugging, etc. But since it's an optional IDE, Squish Runner can be executed headless, so by its command line interface. And basically, while Squish Runner is executing the test script, it communicates to the Squish server. And the Squish server is the instance that knows how to communicate to the application under test. How the Squish runner communicates to the Squish server and the Squish server communicates to the application under test may vary from platform to platform, but most importantly, this is not the concern of the test automation engineer or the user that is using Squish for automation. This is completely done by installation. Oh, no. So there's also an architecture involved, a test automation architecture. And the ISTQB defines a generic test automation architecture that is in turn developed and specialized for every project. And as every architecture does, it defines several layers. Here, several layers with several dedicated purposes. And important for this talk to understand is that on the test generation layer, on the very top of this architecture, we are talking about manual design. That the test definition layer is all about the language to define test cases and their test data. The execution layer is responsible for executing the test, so it's the runtime and generates reportings and loggings. And at the bottom of this architecture, there's the test adaption layer, where all the technologies and libraries to connect to all of the endpoints that need to be automated are located. The last definition of this introduction is the one of end-to-end testing. And end-to-end testing is a test type in which business processes are tested from start to finish. end-to-end under production-like circumstances. And usually, end-to-end testing is performed at the upper third of the test pyramid here. In general, we are talking about system testing. It may also involve acceptance testing, and it may involve some layers of integration testing, but again, in general, we are talking about system testing. And usually, end-to-end testing is done with black box testing approaches. And the black box testing approach basically means the system you are testing, the system under test, is considered a black box, hence the name. You are verifying the system's behavior on its external interfaces only. You do not care about any details about subsystems, about hardware, about software details. It's all about the external interfaces that you are verifying the behavior. Okay, so let's talk about a few major challenges that we are facing more often than others, and that are reoccurring from client to client in the context of end-to-end testing. And three of those major challenges are: testers are not developers. So the focus should be on designing and automating test cases and not on learning any programming language details. Even though that we are talking about embedded systems, nowadays embedded systems usually are embedded in their system that has multiple endpoints involved. For example, you have REST APIs involved for some sort of gateway to the cloud. You have web applications for the backend. You have a companion smartphone application. If you think about automotive, you have communication buses like CAN or even Ethernet-based. So the challenge is that we are facing multiple endpoints here that need to be automated for testing the business process from start to finish, end to end. And of course, since we are talking about business processes, every stakeholder shall be involved. We do not want to involve only developers and testers. Since we are talking about business processes here, we want to involve also the management, requirements engineering, system engineering, sales, marketing, you name it, every department of your company that has any stake in the business process. So now that we know about these challenges, we are going to look at the motivation and ask, why are we proposing the tools and frameworks and approaches we are actually proposing to overcome these challenges? So why would we use Squish? Because Squish is a powerful tool chain that consolidates multiple endpoint technologies to a single one. And basically, this is the key to reduce the complexity on the test adaption layer of our architecture. Why would we use Robot Framework? I have not mentioned Robot Framework yet explicitly, but maybe some of you already spotted that the example test suite with the example test case with the keyword-driven testing definition was written with Robot Framework. And basically, this is the answer to the question, because Robot Framework provides us with a keyword-driven test definition layer according to the ISO. And as a benefit or as a bonus, together with Python as its underlying programming language, it also covers us on the execution layer. And last but not least, it is an open source framework which has a great open source community, even with a dedicated foundation which takes care about developing and quality. So to summarize it, Robot Framework and the keyword-driven testing approach is key to involve every stakeholder because of the keyword-driven approach, and is key to also reduce more complexity on the test definition and the execution layer of our architecture. I hope this question is obvious now. So why would we use Robot Framework together with Squish? is because we want to bring together the best of both worlds. We explicitly want to have the positive aspects of keyword-driven testing. And for sure, we want to have the reduction of complexity by automating multiple endpoint technologies with less tools, maybe even with only a single tool. So to visualize it in the architecture, once more, robot framework is covering us on the test definition layer. Robot framework together with Python is covering us on the execution layer. And on the test adaption layer, we have Squish with a little bit of the help of Python to make Squish talk to robot framework. So with all of this background information, I am handing over now to Miguel, who is showcasing you a real-world project that we are, again, currently implementing with one of our clients, and tells you how this approach looks in the real world.
Thanks. Does it work? Yeah, it does. Okay, let me get one sip. Now, let's begin with the practical experience. Thanks, Björn, for introducing the theoretical background, so to say. And now let's see how we implemented this. Just so you guys keep it in mind, this is a project for one of our clients, so some things might look simplified than it actually might be in real life. Let's begin by setting the goal again. The goal is we are automating end-to-end tests via the UI automation of embedded devices. What kind of devices do we have? The devices that we are working with are basically smart home appliances. When we think about smart home appliances, we should think about heaters, electricity storages, central ventilation systems, gas boilers, in this direction. And all of these devices are managed by our client using a series of applications that are available on Windows, on iOS, on Android, and the web. Now, all of these applications take part into different aspects of the project life, of the product lifetime. For example, some of the applications are used by technicians to make sure that the devices are in the correct status, or to handle the maintenance of devices. For example, one of those devices, it broke at your home, and one of the technicians needs to come and update the firmware. Those are the kind of things that we're going to work with in these platforms. Regarding the tech stack, we are using the following software. We are using Robot Framework 6.0.2. We started using Robot Framework 4.1.3. We ended up updating because of some dependencies we have with other components that we needed to integrate into our project. And we are using Python 3.10, 64-bit, for the same reason. We have some dependencies that we need to take care about. And we were using Squish 7.1, 64-bit. From the physical devices point of view, we explored different solutions. We tried to use Docker with Linux images, which we were not able to because our client software runs only on Windows. Then we tried to use Docker with Windows images, which was also not a working solution, mainly because the Windows Docker images do not have any user interface, which means that we were not able to run UI automation on them. Lastly, we also tried to work with some virtualization, but this didn't work out because of the IT security policies of our clients. So in the end, what we are working with is physical devices. This means that for every test bench, so to say, that we have one computer which is running Windows 10. Then we have one of those DUT devices, which can be a smart home appliance, heaters, electricity storages, etc. And on the last step, we have one Android device or one iPad device. Keep in mind, we're also working with Windows and the web, so we really only have these two devices where they are needed. Next up, to put it into some kind of perspective, we're going to show you what the first approach would be like. Let's say that we want to work with all of these platforms. We have two mobile devices, we have one Windows device, and one web device. The first approach would be to use Appium for mobile devices, maybe AutoAid for Windows, and maybe Playwright for the web. This is just a quick sketch. Now, the problem that we're running into is that all of these tests, they use three different technologies. Sorry. They use three different technologies, which would require us to write in three different programming languages, and keep in mind that our users are not that tech-savvy, because our end users here are mainly industrial engineers who know how to test these devices. So if we are asking these not tech-savvy users to learn to debug three different technologies, yeah, we might run into a bit of a bottleneck there. So what we are going to do is that we are going to use Squish to unify all of those endpoints into one single endpoint, and then provide them with an interface written in Robot Framework. As you guys can already see, we are taking a lot of complexity out of the table just by giving them one single technology and one single, sorry, I keep pressing it, one single technology driver. This is a big picture of how our environment looks like, just so you can see more or less how everything is connected to anything else. Mainly, we have here a test runner, which is the computer that is actually running the commands to connect to the devices and run the test cases. We're running a Windows tag with Jenkins, Robot Framework, and Squish. This test runner is connected to the license server, because this is required to work with Squish. We also have the Windows application and the browser running on this device. Yeah, so here you guys can see how all of these devices are connected with our computer. The Android device is connected via USB. The iOS device is connected via LAN, because this is how Squish works with iOS devices. And all of these devices are then connected to the actual device under test via Wi-Fi, because these devices have an internet connection. So what kind of use cases do we want to automate? We want to use the Windows application to flash new software on these devices, as I mentioned at the beginning. And then these two use cases are pretty much the same. We want to use the Android app to configure and set up hardware devices, and we want to use the iOS application to do basically the same. And we are going to use Squish for these three platforms. One last thing that we need to keep in mind is that we are working with end-to-end tests, which means that our environment is not going to be just automating this kind of stuff. We also need to make room in our framework to include other components, because as we are working with these kind of devices, these embedded systems, they have their own communication protocol. So we want to make sure that as we are interacting with the application is sending data to these devices. We want to make sure, by reading data from devices, that the application and the device are communicating correctly. So, our tasks. We need to develop this framework to allow end users to automate these kind of things. We need to integrate this framework with the existing software that our client has. And additionally, we need the framework to be easy to learn and clear to use, because once again, the kind of end users that we're working with are not that tech savvy. Once again, they have an industrial engineering background. And ideally, there would be a one-to-one relationship between test case specification and implementation in Robot, something that we can achieve using this keyword-based approach. OK, now let's go into the architecture. So we develop the framework, and we provide our clients with the keywords for their tests. The client develops their tests, and we build the bridge between the test cases and the technology driver, which in this case is Squish. So let's focus on the architecture. On the right, you can see Squish. I don't know if anyone knows about this, but Squish has a Python interface that is free to use. It's basically open. You just need to set the paths in your Windows terminal, so in your Windows environment variables, so that you can actually import this set of libraries from anywhere in your system, which allows you to write Python test cases using Squish. And you will be able to communicate with all of the functionality that Squish has without needing to open the IDE. So what we do here, because this is our component, this is us. On the left, you can see a series of test cases, number from 1st to 5th, a UI automation file, and the Squish wrapper file. So the first thing that we do here is we build a Python file that wraps over Squish test, because it is not possible to import this library directly from Robot Framework. So we needed to add some middleware here to handle some things. And then we build a Robot Framework resource file that has all of the keywords that are going to be used in this series of test cases. Here can we see an example. We are defining some keywords here. We are defining launch application. We are defining tab element. Of course, they have arguments. It's just a simplification. And then Squish wrapper has the actual calls to Squish, because if you have worked with Squish, you can recognize that these are some of the functions in Squish. OK, now let's focus on keyword design. Basically, all of the things that are somehow related to Squish are kept on the Squish wrapper part, and everything that is domain-specific is kept on UI automation. Now, the great thing of this approach is that testers can build their own keywords. They can just create new resource files and then make sure that they are imported in the test cases, and they can extend the functionality of what we do. We can see here an example test case on the right. Keep in mind, this is an oversimplified version of an actual test case. So we can see here that we are running a system update. And this system update has 3 highlighted instructions here, because we will go into detail in the next slide. But basically, we can check that this is rather easy to understand. We are selecting a Wi-Fi connection and confirming. We are selecting a device with the following name. And we are saving a PDF report to a documents folder. So if we go in detail, in the first one, we have the click instruction that we have defined in our UI automation wrapper file, the argument that is later passed on to Squish, and a series of robot framework functionality that we take advantage of, for example, waiting until this keyword succeeds, etc. Now, the following examples are more or less on the same line. We are selecting a device with a name. We are also using this click instruction that we have defined in our UI automation file. And by saving the PDF document and waiting until the PDF save dialog comes up, we're doing the same. All of these click, type text, and click instructions are defined in our UI automation wrapper file, and they are then wrapped and sent to the Python interface that Squish provides. So that would be everything from our side. We are now going to focus on the conclusions of what we have learned in this project. Basically, the biggest thing that we have learned here is that Squish is a great tool for unifying all of these environments in one single tool. As you guys have seen in some of the slides before, we have been able to reduce a lot of complexity by using one technology instead of 4 different technologies. Another great thing is that maybe this goes hand in hand with the previous one, but it's so easy to integrate this in Python-based environments. It's just make sure that the path is set, and you will be able to import this library. The UI inspector is available when developing tests. This is something that is only really available if you are using the IDE to develop tests. And regarding the technical limitations that might be a deal breaker for some, I'm going to focus on 2 platforms, iOS and Android. The iOS thing might not be a surprise to anyone, because if you have worked with iOS, you know that Apple is pretty strict with security and this kind of stuff. So When working with iOS and Squish, Squish needs to run inside of the process of the application. Due to the process unboxing on iOS, Apple doesn't let Squish see things that are running on the operating system. So if your application needs to interact with Wi-Fi networks or needs to get permissions or something like this, you will not be able to see it. So keep that in mind. And the second thing is regarding Jetpack Compose. Jetpack Compose is this new framework that has appeared for developing Android applications. And Squish doesn't really behave that well with Jetpack Compose currently. The last news we had is that this is still a work in progress, but I'm sure they will do a great job there.
Okay, thank you very much.